Hey guys, welcome. Let's dig into the learning goal on page 10. It says, prove the theorems about triangles, use the theorems about triangles, and solve these problems. These theorems might include measures of interior angles, like the triangle sum theorem, base angles of isosceles triangles, segments joined by midpoints of two sides that are parallel to a third side and half the length, and the medians of a triangle to meet at a point. Ooh, so there's quite a few theorems that might come into play on this question. Okay, so let's take a look at this first one here. Click all that apply. So hopefully you're seeing this triangle here. Right. And we see this angle is 20, so we know that's 20, correct? Angle 1 is vertical with angle 60, so I know that's 60, correct? And so the blue triangle has three different angles. One angle is 20, one angle is 60, and the other angle is angle 3. And they all have to add up to 180 because that's the triangle sum theorem. So this would combine to make 80. And if we subtract it from 180, we know that angle 3 has to be 100. So that should make sense because if we double check our work, 100 plus 60 plus 20 makes 180. Okay, now what else? Do we know select all true statements if these are parallel? So if these two lines are parallel, then if you see a Z, that's AIAT. See this Z? If those are forced to be parallel lines, then angle 2 has to be 20 as well. And notice this is a straight line. This has to add up to 180. So 20 plus the 100 plus this angle 4 has to also add up to 180 because that's a straight angle. Straight angles are 180. So this would combine to make 120. If I subtract 120, we get 60. All right, and we could check our work. Yeah, 100 plus 60 plus 20. Same three numbers we had before. So is angle 2 60? No, it's 20. Is angle 3 100? Yes. So I'm going to check that box. Is angle 2 plus angle 4? So angle 2 is 20 and angle 4 is 60. Do those add up to 80? Yes. What about angle 2 is 20 and angle 3 is 100? That adds up to 120. That does not add up to 80. Is angle 2 20? Yes, angle 2 is 20. I have checked all that apply. Question number 2. What is the measurement of B in the figure? So I like to flip this thing. I'm going to spin it around and set it on its base. This is what I would call its base because that's how we normally see isosceles triangles. So I see that if this is 62, then this is 62 because it's vertically symmetrical. I could fold it right there and this side would match perfectly on top of there. So if that was 62, that would be 62. So there's a theorem that says that if two sides are equal, then those two opposite angles would be equal. All right, what is the measure of angle B? Well, don't fall for these tricks here. They're not really asking for a base angle. They're looking for this other angle. So I'm going to call that X. And I know triangle sum theorem, all three of these angles have to add up to 180. Just my regular old triangle sum theorem. So X plus 124 56. And that's one of our answers. And we can plug that in and we can check it. Is 56 plus 62 plus 62 180? And I think it is. Question number 3. What is the value of y? I don't have a picture. Oh, so it says use this picture for 3 and 4. Okay, so this is y, correct? And so that's y because they're vertical. And I guess we have to start with this one, right? These 3 angles would add up to 180. So we can combine these two and subtract 97. And I get 83. So if this is 83, this would be 83. And now I can add up these to 180. All right, so now these would combine. So what is y? We got 83. What is x? We got 59. Well done, gang. Okay, number 5. What's the value of x? Notice we have an expression for each angle, and just like anything else, they should all add up. So the 3 angles have to add up to 180 because of the triangle sum theorem. So whichever one you call the first angle, I'll call this one the first, and then the second, and then the third. I've just substituted those in. Now, anything with an x can be combined because those are like terms. So that will be 2, 4, 6x. These items can be combined as well. So 15 minus 33 is negative 18. So let's solve. All right. We gotta divide by 6 on both sides, and we get 33. What's x? What do you know? One of our answers was there. Well done, guys. Question number 6. They took away your picture, didn't they? Those brats. Okay, so I'm going to draw it based on what they tell me to draw. So if this is 90, then this would be 45. So I'm going to draw angle y pretty close to that angle. That's my angle y. It's 48 degrees. Now it says in triangle XYZ, angle y is 48. And they also say angle x is less than. So I'm just going to make this really pronounced. Make one big and one little, right? So see how I made one obtuse and one smaller. Okay, so x is less than y. So I'm going to pick this one for x. And this definitely looks less than the 48. Okay? So what does this end up meaning? If x is less than y, then this has to be shorter than this side, which would be longer. So write the sides of the triangle in order least to greatest. Well, if this is some number less than 48, like let's just say that was 30, see how this leaves a very big number here. I don't know what it is, but it's definitely going to be big. So this side's going to be the longest, and I don't have any other way for it to happen. So if I'm ordering these sides least to greatest, the shortest to longest, the shortest side would be YZ because it's opposite the smallest angle, the one that's even smaller than Y. The medium side, I called it longer because it is longer. It's opposite the 48. So angle 48. We line up the angles, and then we can line up the sides that are opposite that. So angle 48, the side opposite that is XZ. And this is something less than 48. And this is something much greater than 48. This angle Z. So the 48 is angle Y. And this angle less than that is angle X. So what do we have? The last side is the longest side, XY. So I've ordered them least to greatest. Well done, guys.